Autonomous, Hyderabad, School of Computer Science Engineering, in collaboration with the Computer Society of India, Hyderabad chapter. We cordially invite you to join us for day 5, 1 week online faculty development programming on emerging tools, techniques in cloud computing and data science. Talk by eminent expert, today eminent expert, Dr. Sharat Babu sir. Presently, sir is working as a director product engineering in the Iron Mountain Company. Sir is completed IIM Indore, executive programming and digital transformation pursuing. Sir is pursuing the digital transformation from the IIM Indore. Sir is the university topper from the master degrees in computers. Sir is leading innovative changes in the US Berkeley and cloud architecture certification. Sir, areas of expertise is CSE, DMS, IDP, intelligent document processing, insurance, life and annotation, LOMA and level 1, ED and EA technologies, Visual C++, Java, J2EA, machine learning, PM, PMP, ITIL, INS 21 area of interest. And Sir experienced many startup mentor, Oracle ambassador for startups, party of jury panel, machine learning, build, add-on, even May 2021 to Oracle Academy, keynote speaker on various academic and industry events. Experience with the participation in the panel discussions and mentor talk connected in the 75 odd engineering colleges, smart learning, article published in the open sources online education, articles published in the open source for magazine from February 19, 2019 edition, and also part of the jury panel of the youth talk, blogs on the leadership and emerging technologies, and mentoring of the government school students for the NMM scholarship examinations, and 25 years of proven experience and established the track record in successful product development, strategy, delivery management, handling the cross-functional responsibilities. Current role is playing a leadership role, managing the key product platform solution portfolio from the content service platform, document management, intelligent document automation, cutting across industries like BFSI, healthcare, public sector, etc. Product development experience also is there, experiencing the leading terms across the life cycle covering the development software and architecture infrastructure, and global experience. Worked as a defense clients across the global, that is the USA, Europe, handle the peak team size of the over 100 on-site experience in the US part of 3 years. And management experience, hands-on experience in the accepting the customers with direct responsibilities of managing the contracts, customer advisor, offshore transition and implementations, employee and customer satisfaction, and managing the budget and PL. And now hand over to the sir. There is sir.
Good afternoon, Dilip, and good afternoon all. First of all, am I audible, Dilip?
Yes, sir, you are audible, sir. Can I stop my sharing, sir? Yes, you are audible.
Yeah, please. Yeah, you can share. Stop. I can start sharing my content.
Yes, yeah.
So yeah, first of all, thank you, Dilip, and thank you to Narsimha Reddy College for giving me this opportunity to interact with you all. One quick request is, can you guys go on mute, because I'm getting some noise. Yeah, if everybody goes on mute, that will be easy. But yeah, I think please feel free to raise your hand if you have any questions, you want to ask anything. So coming back to this session, first of all, as I mentioned, I'll be speaking on the data science today. So I'll try to really run through some of the, because I know like you're all faculty, you might be interested to know how the data science is applicable in the real world, what use cases are really getting what do you call implemented using data science, what are all the various data science tools and technologies, and from a career standpoint, what is that you need to learn, you need to do. So I think these are some of the questions you might be having. So I'm just hoping that I'll try to answer or address those questions as part of the session today. So I think I know like Dilip sir given a very warm introduction. So I'll not go again on introducing myself. So I'll just jump onto the topic. So before even jumping on to data science, what exactly is the data? So that is one thing. Everybody has so many perceptions about the data, information, knowledge, wisdom. I think there are so many things, right? And we talk about content. So what are all these various terminology and how all these are related? And I'm sure that you might be knowing um, data is something which is very raw in nature, right? Suppose if I take an Excel file, let me just open an Excel file, and if I say, let's just open a blank Excel sheet. Suppose if I say 25, right? So what is this 25? It doesn't say anything, right? Probably 30. It doesn't say anything. This is just raw data, right? But if you really want to derive some information from it, what exactly 25 is trying to convey? What exactly is 30 is trying to convey? Suppose if I say this as age, then this is nothing but this will become a information, right? So any data by itself will not convey anything, but if it gets qualitative or by something, right, some qualification, if we add, if at all, if it is age, it can convey age. If I put marks, it will say marks. So that is what is your information. Then you may be wondering, what is knowledge? So knowledge is like, for example, I started putting this as marks. So I can keep on adding 45, 50, and probably the max marks is, say, for example, 60. So I can keep on adding these numbers like this, right? So what is that knowledge I can gain from this? Means any insights from this. Suppose if I say this is class 1, and suppose this is, say, class 2. Class 2 in the sense some class. So it may be a PG class, undergraduation class, or whatever, some class. And suppose if I take this numbers, and I will just play around and say probably okay. So if I just instead of sum, probably average, if I can say, one second. So what is that it is saying? It is giving the average as 39, and if it is an average as 45. So what is this? This is some kind of insights. Insights in the sense, hey, class 2 is performing better than class 1 is what? Some conclusion you can make, some insights you can derive, right? So this is kind of, so you started with the data, then you kind of qualified it with some marks, such that you know that this is the information about marks. Then you kind of derived some more details on the average of the each class, so which is giving some kind of insights to you to say that, hey, class 2 is performing better than class 1. So probably you can review that. Probably the principal or whoever can think about, hey, I think what is that we are doing differently in class 2? Whether the faculty is same, whether the faculty is different. If the faculty is different, what is this class 2 faculty trying to do? How is there any best practice I can probably copy from class 2 to class 1 to increase the average? Or not only one class 1, probably if you really take college as a whole, you may be having so many sections and all. So what is that I can do, or what is the college can do to really better or learn from each other or cross-pollinate from each other? That is your insights, that is your knowledge, right? So like that, we keep on expanding on the data to information, information to knowledge, knowledge to wisdom. So I think that is what is the beauty of this data, right? So that is the reason today everybody says that you have to do things data driven, in the sense anything will be, okay, what data you have? That is what people ask. Suppose if the sales are happening properly or not. People want to know what is that, what is the, what you call, the background for that. So that means you may take a sales from last month, last quarter, and you can do the analysis, and then you can figure out, hey, probably some regions are doing good in the sales, some regions are not doing good, whether salespeople need more training or salespeople need more support, or what else is required to be done, how to improvise the 6 scales. So all that can be possible only when you have the data, right set of data available, right? That is the data part. Hope it is clear so far, right? Yes, guys? Okay, I assume you are clear. Then what is science? We always talk a lot about science, but, and also we talk about technology, right? What is science versus technology? Science is basically anything which is fundamental, which is foundational. And the technology is something which is like which helps the science to scale. In the sense, for example, I'll give a very simple example. We know that by fire, you can burn a wooden plank through fire. Okay, that is one. Science has the science tells that the wood has the capability to get burned, right? And that is a small thing which would have been invented. Similarly, if 2 rocks gets some friction, it will also generate fire. So that is a very fundamental thing. But we didn't stop, right? The human didn't stop there. So what we did was, we kind of provided the technologies. How is that science can be leveraged, used, right? So in that context, you can say that, hey, I can create a technology through which probably that science can be leveraged, right? So that is where your technology means all your tools, techniques, and all that will comes into picture. So even, for example, in the computer science, data structures is one topic which can tell about how the data can be organized. Whether you can put the data in the form of a stack, in the form of a queue, in the form of a linked list, or whatever, trees, graphs, whatever you talk about. But what is relevant for what? In what scenario I need to use probably a stack? In what scenario I need to use a tree? In what scenario I need to use a graph? So that is what you will be understanding as part of the theory or science. But how is that will be leveraged? That means these things can be leveraged. The tools which can help in doing that or in implementing that is your technology. That is nothing but you can use your Java, you can use your Python, you can use any other languages to implement that, right? That is your technology. But just writing a program or doing some small problem will not be sufficient, right? What else you need? How is this will be helpful in the real world? That is what the exact use case, in the sense like, exactly, there is a science has invented something, there is a technology to implement that. But whether the technology, whatever we are trying to use to implement, will that be of any use to the society? That is what is you will try to innovate, right? So for example, if you take the same wood, fire, and all that, so they invented that by burning these things, you will get some energy and all. People started using it for cooking. That is the kind of the implementation of or application of that concept. Then what is the innovation from there is, now you have all big chimneys at our kitchens, which are making it no smoke, no this thing and all that. That is what is your innovation, right? So data and science together are going to, that means basically the data with all the computer science application, we will be able to derive a lot of societal benefits, is what we need to probably look at. So coming down, I have listed some use cases here. I'll not probably talk each and everything which you might be already knowing. For example, if I start with an healthcare, you all go to hospital sometime or other, you may go for a test. Suppose if you go for a blood test, then what they will do, they will take a blood and they will put it on a glass slide and they will give it for analysis. So that will be put it under a microscope, and then you will be able to really look at how is the pattern and all that, and you can detect whether there is any abnormality and all that, right? Science is related here. Means, suppose, assume that now today there is a technology to scan these glass slides. So hospitals have, they use a term called digital pathology. So it's a big ocean again, that subject. So basically what they will do is they will take these slides. The way you scan your pages, paper or documents, you can also scan these slides. So there will be big scanners. So if I can probably open and show you something in Google, what is digital pathology scanners? I'm just showing some images for you to see how they look like. They look like this. What it will do is, it will have starting from 10 slides, 100 slides, 500 slides, 1,000 slides. So that means at one time, the way you can image a paper, you can image a slide. Okay. And once these slides gets imaged, the glass slides, I mean, gets imaged, those glass slides will be shown on your, that can be now it's become a software. Now it will come to your computer. Now what you can do, now you have big whole set of images with you, right? You can do a lot of analysis on the data, especially some of the complex diseases like cancer or some of the other things, no? Which needs, because still we are in the research to really conquer the disease. So we may need a lot of data to understand the patterns, how it is happening, why it is happening, what is the root cause. All that can be analyzed. For analyzing that, you need data. And as you all know, one second. Okay. So as you want to analyze, you need more data. And when you have more data, you can apply your artificial intelligence, machine learning techniques, and you will be able to understand what are the anomalies, where exactly the pattern is looking a little different. And then you will be able to explore. So if you really see all the big hospitals, AIMS, NIMS, a lot of this are really looking at or using this scanner. So this is just one use case, because I don't want to really read each and everything. Other things you can probably, but I'm telling the power of data. Because if it is in the physical form, you will not be able to do anything. But if it has become converted into digital form, then you can do a lot of AI ML techniques, apply on that, and you will be able to do of things. So like that, no, there are so many. I'll take one more example. So here I talk about healthcare. Let me talk about the fraud and detection and all that. So you all, typically, if you take any banking or financial services institution, one common use case, which you all know, is KYC, right? The know your customer. What is that know your customer does? You might have gone through it, because when you want to open a bank account, you will go to the bank. Then what they will do is they will ask your Aadhaar, they will ask your driver's license, whatever, some ID proof. There will be another one for address proof. So what they will be doing, they will be taking that documents or the ID cards, and they will be going to, for example, if you have given an Aadhaar card, what they will do is, there is already an Aadhaar database. What they need to do, they need to take the image of your ID card. They need to take and compare with whatever is there in the Aadhaar database, just to see if that matches or not. And in between, you also need to make sure that if the document is properly scanned, the quality is good. If there is any tampering on the document, those all are nothing but your fraud detection techniques. Not only that, for example, based on your profile, they also need to categorize or put you into whether you are a low risk person or a high risk person or a medium risk person. When I say low, medium, high, how I will be able to categorize? For example, in the same banking example, suppose if you are a salaried employed, and suppose if you are working in a government organization and you don't have any other involvement and all that, then you can easily say that this guy is a low risk person, because you know that he'll have a steady income every month. He's working in a government organization. There is a job security and all that. That is why you can classify them as a low risk. Suppose if you are running your own business, right? So in that case, what we will do, business is always, there will be up and down. There will be this side, that side. So what we will do is we'll keep that in the medium risk, because for that also what they will do, they will verify last 5 years, how the business is performing, whether they're earning profits, how are the debts, what kind of loans the business has. Suppose if the business has too much of loans and all that, then they will be probably putting them in high risk. And if it is a lower this thing, they can probably put him in a lower this one. So like that, you can be categorized as a medium risk. Similarly, if you are really doing your business, say for example, in countries where there are sanctions. For example, now you know, right, with all the Russian-Ukraine war, I think there are sanctions across the world from on Russia and all. Suppose, or if you are working, if you are having business which has some presence in other countries where there is a war going on, where there is something else happening. So in that case, no, there you will be put it as a high risk. So why all this is required? All this analysis is possible only through your data. So I'm gathering a lot of this information from you, and I'm just trying to really categorize or segregate you into either of these buckets, such that I know like where exactly the high risk people are available. And then what is that we will do? For the high risk people, it's not like we will deny giving the loan or we will deny giving an account. But what we will do is, for the high risk people, we will keep doing these checks more regularly. We'll keep monitoring them. And that way, at least if we really see that, hey, there is something going wrong, then we will probably take an action immediately, right? But if there is a low risk, we don't need to really keep too much of monitoring on that. Hey, that is a government job, regular income and all. Now, the reason why I'm telling these examples is that you need to understand that for anything, last time when we discussed about, in the last example with healthcare, imaging, digital pathology and all, the data is the key. Similarly here, to really segregate the people into various categories, again, data is the key. So that is the reason data is becoming so this one. So with that, then you might be wondering why this data science is so important now, why it was not there 15 years back, 20 years back, 25 years back. Means you all know, right? We have something called a Moore's law. They know the power of processing, computing, storage, all this, especially compute. Compute is getting more and more cheaper, more and more scalable is one part. Similarly, the storage also from internet only. If you can really see here, in the 1986 time frame, the digital was nothing. It was, everything was analog. In the sense, it is all books, papers, some kind of discs, whatever. However, as the time passed by, if you see the analog is in the green and your digital is in the yellow, right? So all this is slowly started getting stored in the digital media, be it disk or whatever, from the books and papers and all that, right? So this is the way, the tape and all that is still analog and all, but I think the disk is the digital is what is this one. That is the reason if you really see all the video tapes, VHS and all that is analog. At that time, if you really want to store anything, you are storing on films. Today also, you can see some organizations use microfilms to store things and all. And from then we started building all these small floppy disks. Then we got into discs, DVDs, Blu-rays. and now it is all cloud, right? But whatever you say, everything, because this diagram is old, it is talking about 2007. So now started in 1986 to 2007 means what? 96 2006. That means 20 years. In the 20 years time frame, this has grown very 2.6 to 19, but this is 0.002 to 280 exabytes, right? So that means the way the digital has penetrated, and you all know advantage with the digital, right? Because these things are easily searchable, they can easily be um, um, accessible, it is fast, all those advantages will be there. So that is the reason actually the digital has helped in making all these, whatever the examples we have seen, be it the banking example or the healthcare example, all that is possible because now the data is very abundantly available in the digital format. It is cheaper, it is quickly searchable, retrievable, and all that. With all that, no, this has become more easy and comfortable and all. Okay, so with that, let's go back to the flow where I have started. So these are just to give you the glimpse of what are all the use cases we have, right? So this is, I'll just summarize what we covered. We covered what is data, what is information, what is knowledge. We also told about what are the use cases. One, we covered one healthcare use case, we covered one banking use case, right? Like that, no, you can talk multiple. I think you can tell more than me, looking at the way the data is getting leveraged. So with that, let me jump on to one quick thing. This is just, you might be wondering, okay, Sharath, you are telling all these things. What is really the opportunity in the data science or in any of these things? Do we really have opportunities? I mean, whether if you really want to start up a business, or if you want to really get into a good career or good job, or you want to really encourage your students to pursue this career, what is that which is really the opportunity here? Why we need to pursue data science, right? For that, I'll go, before even jumping onto data, I'll try to keep it a little generic, and I'll try to really talk about what is the overall IT spend, right? So if you really see the overall IT spend, last year, because of all the COVID and all, I think we are talking about what? In 2023, it is only 3.3% growth. But in 2024, they are predicting that the growth rate will be 6.8%. And you might be knowing Gartner is this is the way which is a benchmark for the industry. It tells us every year on year how the market is going to be, which industries are going to really prosper and all that. And so it is going to touch 5 trillion in 2024. That is what is the prediction. And similarly, if you really look at the Gartner for India, we are talking about what? A growth rate of around 11%, 10.7%. And which is going to be around from 113 billion to, we are targeting to touch around 124 trillion. It's not trillion, it is billion. I think that's a spelling mistake. Okay, so this slide, I'm only want to use it for giving you the numbers. So I don't want to really use it for more. But one interesting connection from here I want to make is, okay, your next question may be, okay, Sharath, worldwide IT is this much, India is this much. What is that data science opportunity, right? So for that, we will try to go to one more slide. This will give us some insights on what is that which is really relevant for data science. So this is probably some report sometime. It may not be latest, but at least it will give some idea. They are talking about was the data science platform market size was valued at 64 billion in 2021 and projected to grow from 81.47 billion in 2022 to around 500 billion is what they're talking about 2029. We are in 2024. So even if you really take another 5 years, I think the potential of data science is going to be this much, and the growth is going to be around this percentage. Okay. And the other impact is, if you really see here, year on year, how they are growing is something they were telling, okay, in terms of the billions. And okay. So in terms of the data science across industries, and the reason, if you see 22.7 is what has been for the BFSI. So seriously, BFSI is nothing but banking, financial institutions, securities, and insurance. So that is going to be the bigger, it holds bigger share of around 22.7. And similarly, there are IT and telecom, healthcare, retail, and so many other areas. But I think and one important thing you all need to remember is always the fintech is quick to adapt to the technology. So anything new technology comes into picture, the banks and these financial institutions, they will adopt very quickly. That is one, and even healthcare also is another one. So that is the reason I just want to let you go nice. Okay, even if you really look at the continents, they didn't provide the numbers here, but they provided US, North America is US. And let's see if they have any more details. Segmentation. Segmentation is something I think we have seen already, right? By deployment, by what you call, where is that I got? Enterprise deployment, okay, this is fine. Infographics is with respect to I think trends and all that. I think you can look at all this. It has a lot of information about on-prem or cloud, small enterprises, large enterprises, and all that stuff, right? So BFSI is having big one, and North America is having this much. Put all the key players on this. So Databricks is there, Oracle is there, Microsoft is there. So a lot of these big companies were there. So I think this is all to give you an idea of why it is important to really understand and learn about data science. So I kind of tried to provide you a glimpse of world opportunity, and then got into India, and then got into the data science opportunity. Fine. So with that, let me go back to my original slide. Okay, this is from here. That is the only thing I want to talk. Other things probably may not be relevant for you. Coming here, how the business is evolving, because now you mentioned there is opportunity in banking. Now we mentioned about so many other areas, right? Telecom, healthcare, and all. So with all that, now you might be wondering, what is that? How is that I need to really, how is that the business is evolving today? In the sense, this is the transformation part, right? And this is the expectations from customers. So the transformation part is more about product to service, in the sense like now people are talking about, instead of just looking at it as one product, we are looking at it as a service. In the sense like, suppose you might have know about the example from Nokia, right? Nokia versus Apple. So Nokia is what? Nokia has kind of faded away because they were not able to. 1 second. Sorry. So Nokia got failed because they focused on the device only. But Apple, what it did, it also looked at, hey, I don't need to only think about the device. I also need to think about the data surrounding the device. the calls, the ecosystem, right? And that is the way they kind of created a platform through which people can develop applications, use the data from that from the phone, right? That way, I think they have created a ecosystem where that is the reason whatever the apps you are seeing today, be it your Swiggy, be it your Uber, whatever you are doing, they kind of created a platform so that that has created a broader volume, and that is the reason actually it was so successful, right? And even if you really look at the customer standpoint, the customer expectations have been increased, because today if I go and visit a website, if it is not responsive, I'll get frustrated, right? And even it might be the case with you also. So the user experience is very important. And also today I may be doing some transaction. So and suppose if suddenly my laptop goes for a toss, and if I'm not able to, then I should be able to shift to my mobile and then continue the conversation, right? So it should be omni-channel, irrespective of whatever the channels you have, you should be able to swiftly transfer that. And even if, for example, if you're doing an order in a cart, shopping cart, and if you are stuck in between, you should be able to move it to your other device, and you should be able to continue and complete the transaction. So there should be a smooth transition of all these things. So the time to market, investment, all these are business terms. So I don't want to spend more time. But what I want to spend more time is on this slide. You keep hearing a lot about digital transformation, right? And again, we all have seen that the data has increased a lot. And if you really see, this is what happens in 1 minute, right? This is as per the 2023 report. And you can see like this talks a volume. So we are talking about what? We're doing this much of content, be it videos, be it your messages, be it your data searches, whatever, content, documents, your chats, your emails, your photos, videos, everything. I think it's huge. So when you have such a huge data, what is that you need to do? How is that you can better utilize that, right? That is where the data science comes into picture. It is going to help you in using all this data effectively, and it also helps you in terms of generating some revenue from all this, right? That is what is the importance of the data. And also you may be wondering, okay, there is so much of data. What are actually the key characteristics? I'll come to this slide again. What are the key characteristics of that data? Means data will be having these few characteristics. Data can be at rest, which is probably just lying in my laptop or hard disk, whatever. Data is maybe in motion, in the sense you are sending it over email, it is going via network, or if you are watching a video or a movie on your OTT platform, the streaming of data is nothing but everything you are getting it streamed, right? So and the way it all works is, you will have, like, probably if you think about getting a little deeper into some of these Amazon Prime or Netflix and all, how they operate means they will have CDNs, the content delivery network nodes. So it's not like everything of Netflix comes from US. No. So there will be a CDN located near to our this one. The CDN will host a lot of the things what you generally watch, all the new movies and all the details, such that you don't need to go to, say, for Netflix means don't need to go to the servers in US and do that. You'll have a CDN, a local, this one where some of these things are available. Suppose if something you asked for is not in this CDN, which is sitting close to you, then you should file a request to the US. The server will download that into the local CDN, and from there you'll be able to access. So what I'm trying to tell is the data is always need not be just rest, but the data floats as part of the communication. So today you may be talking a lot about APIs. So you will use APIs to send data, to receive data. That means both to push or pull the data, right? And data can be in many forms. It can be image, it can be video, it can be document, text, whatnot, right? Everything is a data. And the data can be either structured, unstructured, semi-structured, all that is possible, right? So when I say structured, if you really simply take a database table, you have straightforward rows and columns. So the way I have shown here in the Excel, this is structured, right? I know what is this, what is this. These are two columns and the content is this. So I have a very clear demarcation, right? So this is what is your structured data. But for example, that means a computer program can easily understand and interpret the data. But whereas if I give you a photo or if I give a video, then how is that it will interpret? So that is all unstructured data. And similarly, there is semi-structured data. Some of it will be easy, some of them may not be. For example, if you take an email, it can be a semi-structured. So in the sense, for example, the to address, copy, subject, all these are easy. They're all structured. They are known pretty much. But the content within that, that means the text and all that, whatever the message is not structured. So that is one example for a semi-structured, this one, right? And other important thing is data in doubt, because always no data, the quality may not be good. There may be unnecessary content possible in the data. So we need to really, because suppose if there is a noise, if there is a lot of noise in the content, it will be difficult to derive a proper meaning for that. So that is when you need to think about how we can enhance the quality of the image. So with all that, the data has the volume part, the velocity part, the variety part, and also the veracity part. So these are all the 4 characteristics of the data. Okay. So now, with all this data available, what is that we need to do? So for example, let's take one small use case to understand. Data first will be, say for example, a bank is there. So for the bank is all having its records in, say, paper format. So how is that I can take the benefit out of this data science initiative? Means the important thing, data science, I'll come to the concept of data science, but I'm just trying to tell you the applications of it before that. So suppose I have the paper document. I want to really use that paper document. Means I need to make that paper document first digitize. That means I'll probably scan it, right? Once I get that scanned, now I have the digital copy of the document or the paper, whatever, image. That is the first step. If you take, for example, your college itself, each of, say, for example, student record is one digitized document. Similarly, each of your employee records is a digitized document. That is at the document level or at paper level. Now the next one comes is the organization level. The organization level, what are the things you do? You have various processes. So in the sense, for example, you have an admission department, you have an examination department, you have a department which will plan for all the classes, scheduling and all. That is another thing. So like that, you have so many individual departments, and some department may be focusing on getting accreditations and all. So, and data need to be passed, because the thing is, assume that as part of this particular program, you're doing an FDP program. It's an online event. You have invited so many external resource persons. They have come and delivered lectures. So this is something which is being organized by, say, for example, one of the department head or whoever. But there may be a separate department who will be sitting and getting audited for these whatever the accreditations you guys get to. So this information of, okay, this FDP is conducted has to be transitioned or transformed to or transferred to the department, so that they can use this data and show it whenever the audit happens, right? That is what is the process part. That means this is one process. That is another process. How all these processes communicate and exchange data, that is at the process level. And actual digital transformation is when you have all your data digitized, when all your processes are using that digitized data, and doing your tasks through various workflows and all, that is your digitalization. Once that top to bottom, every department has gone through this phase, then you can say that, hey, I have, as my institution or organization, I have achieved a digital transformation, right? So digital transformation is not just scanning one document or reading one document from that. It is, you need to look at it holistically from the overall institution or the organization, right? So with that, I'll just take a pause and introduce you a little more on the data science. Then I think we will come to some interesting use cases and applications of it. Especially, I would like to touch on the document processing. That is the core area where I work. So I can probably talk a little about that, what kind of work we do, what kind of opportunities we have, and all that. But before jumping on to all that, let me just take you to the data science concepts. And these are all the technological trends which you already know. I don't need to tell you all, but typically, these are the 4 trends. And you might be wondering why now all these trends are evolving, all these emerging technologies are evolving. Means there are so many reasons. One is democratization of internet. Because when I started my career sometime in 99, the internet was something which was very, what you call, rarely available for the people, right? Only companies and all that is used to be. Now, internet has become very common for everybody. Similarly, buying a computer used to be a luxury item at that time, but now it is like everybody has a computer. Sensors, you can have sensors for everything. In some of the houses, you might be seeing when you enter, automatically the lights can switch on. And similarly, when somebody leaves the room, the AC automatically gets switched off. All that is possible through sensors, right? So like that, no social media and all these things, and the interest in the social media, collaboration. Social media doesn't mean that only Facebook or Instagram and all, but if you really look at all your other platforms through which you can communicate, share, discuss. For example, you can use LinkedIn, you can use some of the other places where you can publish your articles. All that is nothing but your, what you call, an important dimension, right? So all this is driving the evolution of all these technologies. And in that, data science is definitely one of the technology. And before even, I'll come to this later. I'll come to GenAI also later. Let's probably focus a little bit on the data science. But I'll just take a quick pause here. And I want to ask if you guys have any questions so far. You are following. Is the pace okay? Am I fast, or am I connecting the dots? Am I logical? Please feel free to let me know if you have any questions, comments. So, Dilip sir, is this pace okay?
Yes, sir. Yes, sir. Okay.
And hope I'm not going fast, right?
No, sir. Right. Yes, sir.
And hope this is resonating with the faculty, I believe, the content, whatever I'm speaking.
Yes, sir. Exactly. Whatever you speak is very useful to the participants and faculty.
Okay, perfect. So let me jump on. So far, we have done all the, what do you call, when you really go to a movie, all the first 30 minutes, 45 minutes will be what? Establishing the story, right? Establishing the characters and all that. So what I did so far was that I kind of took you to the journey of all these elements, what really influenced, what is the reasons of for data science, what is the opportunity window, and what are all the use cases. I kind of tried to get you or establish the storyline here. So now we will jump onto the actual story about what exactly is data science and how it is related and what are all the other components. And we will touch a little bit on some of the data science core technologies and all that. Then we will come to The third piece is like, once you have that main plot getting established, then we will really get on to the climax part, where we can talk about my core area, which is the document processing. And then after that, I think we can think about some of the next steps for you guys to explore more, right? I think that is the way I'll probably structure this conversation. So with that, let me go back to the slide again. So if you're seeing my slide, the data science is a culmination or combination of all these three, because it needs some kind of mathematical modeling. It needs the concept of computer science, be it your networks, data structures, everything is really required. Not only these two things, the main important thing is the business or the domain. So because the application of this may differ from use case to use case, domain to domain, based on whatever the domain you are working on. If it is healthcare, it has to be from a healthcare standpoint. If it is a BFSI, it has to be from a BFSI standpoint. I think that is the way. So overall, the combination of all these things will be the concept of data science. Okay. Then if you really look at the development of software, typically we do have databases, we do have infrastructure, we do have networking and communication, and we do develop the solutions actually using our application software, right? This is basically application software is dealing with some application, be it telecom, healthcare, banking, whatever. And for software development, what is important is you need to know the knowledge of computer science. You also need to know the knowledge of the domain. That means if I am building a payroll application, I need to know the computer science. I also need to know how the payroll processing works. If I know these two, then only I'll be able to develop a payroll application, right? So it is basically the software development is just an integration of these two aspects or intersection of these two aspects. So why I'm talking about this means I want to, in the next slide, I want to tell you what is data science in this context. So if you really, earlier now, we were only talking about this. But if you really come to data science, you also need one more layer, which is your mathematics and statistics. And if you really see the interesting concepts here, if you're really doing some business modeling, what is required? You need some traditional research. You can just have construct. So for example, if you take insurance has what? You need to, for example, underwrite a policy. If you want to underwrite a policy, you need to know a lot about insurance domain. You need to know the algorithms associated. And for all that algorithms and all, you need to use a combination of mathematics and statistics. And also you need to know what is the underwriting from an insurance standpoint. Then you'll be able to apply that for the traditional research part. And this we have already seen, computer science versus domain and business is your development. And computer science and mathematics and statistics together is nothing but your machine learning. But data science is the crux, which has a bit of development, which has ML, which has research. All the three together will be forming your data science, right? So earlier software development to current data science, this additional layer and also all this integration or intersection is going to tell this. Causal algorithms, and this is just a definition from the Wikipedia. So basically he's talking about what? Interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structured or unstructured data. Structured data is in the beginning when we get onto that Excel sheet and put the marks and all, that is your structured data. Unstructured data is if you take an image, video, whatever, that is your unstructured data. So using the values for unstructured data, if you remember, the digital pathology is an example because we are taking an image from the slides. we are using AI ML technologies to understand things, analyze things, identify patterns and all. So that is what is your unstructured. So more or less, data science is related to data mining, deep learning, and big data. All these things together. Because I'll come on to that also in the next slide. So if you really ask me, what is that it takes for you to look at data science as a flow? For example, if you want to really do something with the data, first thing what you need is you need to get the data, acquire the data. That means you need to collect the data. The data collection is the first step. Okay, now once you collect the data, always know the data may not be in a position to use directly. Sometimes it may have a lot of unnecessary data, which we don't want. So curation is nothing but some kind of cleanup of all that existing data, such that it can be easily consumed by anybody, right? So collection is one part, but after collecting, you also need to curate it. You also need to remove unnecessary data. Sometimes unnecessary noise also may come. So you may need, it is like nothing but like you are editing. Whenever people shoot the movie, right? They will shoot with whatever the idea, whatever the story narration they have and all that stuff. But at the end, it may come lengthy also. They need to sit on an editing table and they need to really think from an audience standpoint. Hey, if I put this scene, probably the audience may get bored, right? It's a noise. It may not probably add value to the story. Then what you will do is you will try, as part of the editing, you will really trim those things or remove those things, right? That is nothing but curation. Similarly, in the data science also, you may take data from so many sources. Primary sources, for example, you want to really do some data science project. So you have taken your college data as a source. That is your primary data. Similarly, you may also want to probably take the data from the academics, other institutions, other regions, other geographies and all. That is your next level. So when you really go to that next level, then what happens? You may get data from other sources also through internet, or you may ask your friend to send the data or whatever, or which is available on the public domain. All that you will download, but it may not be in the way you want. What is that you need to again do? You need to do that editing. That is what is your curation. Once that curation happens, then what is that you need to do? You need to analyze. Then always people have confusion between algorithm and model. There are a lot of algorithms, but model is something in our hand. What is a model? Model is something which can help you to predict. For example, go back to the same Excel sheet. Okay. So forget about this. I'll add another sheet. I just want to show you something different. So here I'll say X and Y, right? And I'll say 1, 1, 2, 5, 3, 7. This is 3. Okay. 4, say 9. So I give you this data, for example. Okay. And so then, for example, if I give 7, what it comes? What is it? It will come to. It has come to what? 15. Then you may be wondering why. How did I get that 15? So this is not. I want people to tell. I want the computer to tell, machine to tell. If I give 7, what is it? It comes to. I want the machine to tell. So how the machine will tell? Machine is given these values, and machine is given this set of values, and machine is asked to learn. That is what is machine learning, right? Machine is asked to learn by itself. So what it will do is, then after that, you are talking about what? Learning. Here you want to predict, right? So as part of the learning, what we are trying to say is, based on this, I'll come to a conclusion that, hey, it is nothing but y is equal to 2 into x plus 1. That is what? Because if you take 1 into 2 plus 1 is 3. 2 into 2 plus 1 is 5. 3 into 2 plus 1 is 6. 4 into 9. So you have got a model. This is nothing but your model. Right? Then what is that you are doing? You are predicting 7. That means, okay, now you got a model, but you don't know whether it is correct or not. So what you will do is, you will kind of do a y hash or y cap or whatever. Okay. And what I'll do is, I'll just try to, this is the values you have already given, but I also want to, I don't want to use y as is. I want to use this model to calculate y bar. So that means I will again, what I'll do, I'll just take x and I'll put it in the formula and I calculate. That means it comes to same values, right? So why I am doing this is, I am only trying to make sure that this model is working. Then what I'll do, I'll try to compare this y versus y cap, right? So now what I'll do is, I'll take a difference of y minus, if I say here, I'll just take y minus y cap. Nothing but this minus this. So then what I'm saying, I now know that if this difference is 0, means it has predicted using this model for a given x, whatever the y cap it predicted is nothing but same as whatever is the actual data, right? I think what is that it is trying to convey? It is trying to convey the accuracy of the model. So that means this particular model, what you have seen, what you have derived is now good enough because you already tested this, right? So now what you have derived this model. So now what you will do is, you will not predict now only. You will just take a test. Then say you can go and predict. So these are all, whatever the values I used, these are all nothing but the training set. Then what I will do is, I'll take 7, say 8, say 9. This is my test set. So what I'll do is, I'll apply the model. Then when I apply the model, it will be coming to what? 7 2s are 14 plus 1 15. 8 2s are 16 plus 1 17. 9 2s are 18 plus 1 19. Right? So then it also tested and it has come out fine. So now you can go and do the prediction. So first step will be, you will be deriving the model based on the given data, and you will also check the accuracy of the model. Once you become confident of the model, then you will test it with the test set. Once you are satisfied with the test sets, then you will start putting it in the production and start using that model for predictions. So this is the way, typically, you might be knowing, I'm just trying to tell, but what is then algorithm? Algorithm is, if you really see here in the same Excel, the model what you got is equal to y is equal to mx plus c, right? So this is nothing but your algorithm. That is nothing but your basically underlying mathematics, right? Which is nothing but a straight line or whatever, right? It can be, it need not be just like as simple as a straight line. It can be like a polynomial equation. So you may say x1 square a, x2 square b, whatever, y is equal to something like that also. Like ax, it's a binom, what is it? It's a regular equation also. Ax square plus bx plus c also, right? So what I'm saying is algorithms are nothing but whatever the mathematical underlying these things, because you need to use these values to plot a graph. When you really plot a graph, it can be a straight line, it can be a curve, it can be a hyperbola, it can be anything. All that is nothing but you're underlying this one. So that is the reason if you really like regression is one algorithm. So what is that regression will do always is it tries to fit that line. It can be a straight line or it can be anything. Similarly, when it becomes more and more non-linear, because when you really take x square bxc means that means it's non-linear, right? So I think it can be linear, it can be non-linear. So all that is your underlying things what you can use. So, but model is something customized to your problem or to your use case which you are trying to solve. This is your model. This is unique to your problem. But algorithm is very generic. But model is specific to your use case, right? That is the way you need to understand the terminology. And going back, so you have the analysis of data. The way what we did, I just took a very simple example, but always things may not be so simple, right? So the thing is, there are multiple ways people can predict nowadays, right? You can predict based on, say, employee number of years of experience versus their salaries. Suppose if you have already the data from the past, use the data, and then when a new person joins, if you want to really predict what his salary is going to be, you can always use that. There are like that, no, you can think about more and more and more and more examples. This is only one way of looking at, but if you really look at, there are more, other than regression, there will be problems like classification, in the sense which are more, it can be binary or it can be multicast. What I mean by that is, binary is like when you say, suppose the very common example anybody in the machine learning world uses is the email, whether when you get an email, whether it is a spam or not. That is a very common example. That is a classification. So that means with the classification, what you can do is, whenever a new email comes, you will be bucketing it under either a spam mail or a non-spam mail. That is a classification. Or similarly, if at all, if some scanning is done for somebody, and suppose if there is some this one, then you will be able to tell if it is really a tumor or non-tumor. So all these aspects will be covered or handled through classification algorithms. So it need not be binary. Sometimes, it may be more than one category. Suppose if you want to really have some kind of color, I think there may be three colors in a particular item. Then you can always say that three as more than two also. So that is the way I think we can do the analysis. Then once you have this analysis done, then what is that you will be doing? You are interpreting whatever the new data which is coming out, and you are trying to tell what it is or what it is going to predict. And now, so far it was more about predicting. But now what is happening is, with generative AI, you might have hearing a lot about generative AI. In the generative AI context, people are talking about, earlier, no, when you train an algorithm with a lot of dogs and cat images, then what it will do, when you give another cat image, it will be able to tell you a cat. And similarly, in the sense, it will tell, okay, this is a cat, this is a dog. That way it will tell. But with generative AI, what it will be doing is, it will not only just tell it as cat or dog, it will generate an image of the cat, it will generate an image of the dog. So that is the reason it is generative AI. So generative AI is one step ahead. So far, you are only predicting the content, whether it is that or this or whatever. But it is not like that. You are not only predicting, but you are also generating that. So that is the way it will be looked at. And data science is awesome. Awesome is basically, I kind of try to use this, combine all this. It is, first thing is obtaining. It is obtaining the data. It's same as your data collection. Scrubbing is nothing but your curation. Explore is nothing but your analysis, modeling, and all that. All that. Then interpreting is nothing but your decision making. So visualizing is nothing but you representing the data in some charts, graphs, and all that. No, that is your visualization. Then you might be having this question: what is this data science versus business intelligence? I already put a notes here. So if you really see, business intelligence is used to deal with more structured data, which is predictable, but data science deals with unstructured data. And business intelligence use the typical statistical tools, but data science uses machine learning, natural language processing, and all, NLP and all. And it mostly deals with historical data, but data science can also deal with the real-time live data. So that is what is the difference. Now, so this is something which you might be already knowing. Typically, always we have this question of AI versus ML versus DL and all. So, and data science kind of touches all this, because all these AI, ML, DL deals with data. So that is the reason data science is a common pie or common theme across all the layers. It will touch all the layers. Just give me a sec. I just want to grab some water. And then I think we can just give me 1-2 minutes, Dilip. Okay.
Okay, sir. No issues, sir. Please take a break. No issues. Thank you.
Okay, I'm back.
Yeah, thank you, sir. Your session is very valuable, sir. Thank you. Thank you.
Yeah, no worries, no worries. So let me jump onto the session. Now comes the question on, you all being technical guys, you might want to know what technologies and tools we need to use and all that. So as I was telling, data science has 3 typical areas. First one is the data mining part, then comes your machine learning, and comes your data analytics. So the data mining part is something which is nothing but getting all this. For example, if you take any enterprise level data, that means if you take, for example, a company like a Reliance or a company like Adani, they may have huge data, right? So there may be having infrastructure spread across their branches, departments, and all. So you need to create some ways and means of, because it's all huge data. That means you need to engage the big data concepts there. So that is the reason I kind of, and also when the data is huge, Java is really the best tool to be used, because Java is having 25 plus years of experience, and it has been embraced by all the industry. All the big applications are running on Java. It's platform agnostic and all that stuff. So when you have the data at that high level, this Java and Hadoop makes a good sense. But at the same time, there is a Scala and Spark combination also. The way Java is there, Scala is another language, functional language. And the way you have Hadoop, you have Spark. But so Spark is the big data framework for Scala. So when you are really working on some small projects, POCs, or suppose if your organization want to test something, try something, then I think your Scala and Spark will be sufficient. If it is a big enterprise, huge data and all, Java and Hadoop makes sense. And for Java and Hadoop, Mahout is the ML framework we can use. For Scala and Spark, Spark ML is the ML framework we can use. And training data is the model selection. And testing for this is about machine learning. Machine learning, Python is more interesting because it has what do you call lot of ready-made available frameworks. In the sense, like suppose if you are dealing with matrices, you have a framework. If you are dealing with images, you have a framework. So doing machine learning with Python will be very, 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 very easy. It doesn't mean that we cannot do with other programming languages, but this one will be very, very, very what do you call interesting and easy to use. So you don't need to definitely look at so many things, because Python already provides a lot of ready-made frameworks to be used to do whatever the problem you have. Suppose if you want to convert a file from PDF format to some other format, or you have an image which you want to convert to a PDF, all those things, there are a lot of inbuilt libraries and all that which can do all that stuff. So that is the reason, no, it will be very easy to run through this through Python. And analytics, for analytics and all, R is another language which is really suitable. If you want to really drive some analytics, if you want to really see some good analysis, reporting, dashboarding, and all that, I think R is going to be a better suitable tool for that. And if you can take the a little bit next level, so these are your statistical tools. Your R is one, MATLAB is one, Octave is one. Octave is free. MATLAB is something which you need to pay some license. But they have some smaller, lighter free versions also. Even R is an open source. And if you take languages, you can use either Python or Java, Scala. But for students and all, I think Scala and Spring Framework and Python should be the best one. And if you really look at the deep learning frameworks, Theano is more from someone from an academic driven framework. It's all about deep learning frameworks. These are all deep learning frameworks. And Torch is from Facebook. TensorFlow, you already might be knowing, it is from Google. But each has its own. So Theano is more very at a research kind of thing. It probably may not have a lot of features and all. But if you really look at Torch, the Torch is more, because Facebook is more about what? Facebook is about the images, right? The Facebook is about images. So images means Torch will be probably, that means if your data science project is more to deal with images, then I encourage you to use Torch framework. And if you really want, you have a lot of text-driven projects. You're doing a lot of document processing and text processing. Then I think for you, the TensorFlow makes sense. It all depends on what is the problem you are solving and what is the use case you are solving, right? I think that is the way you will be able to achieve whatever the problem you are trying to solve based on whatever the selection you are going to make. So if it is a language, take TensorFlow. If it is an image, take Torch. Theano is for any research, lightweight kind of thing, you can use Theano. But these are all the tech stack. Suppose tomorrow, if you want your students or yourself want to make yourself dirty with the data science technologies, I encourage you to use Python and Scala, or you can take either of raw for your analytics. And probably if you do a lot of document specific, this thing, probably you can take TensorFlow. That way, I think you will be able to easily learn this very quickly and all. And what is NLP? NLP is nothing but natural language processing as per the definition. But what exactly is that it will do? Means the way we communicate with you, I'm talking to you. You are understanding what I'm trying to communicate. But how we can make machines understand that level? Because you cannot always spoon feed, right? You need to also coach. And if you get a chance, check about an app called Jugalbandi. It's an app developed. It's purely on the language. And this was demoed when some time back. This was actually developed or conceptualized by, I think, IIT Madras. They created this such that, suppose if a village person is there, that village guy, he cannot speak English. But he want to know about the welfare schemes which the government is putting together. Because government welfare schemes may be available in the government websites. But this guy is probably not literate in English. He may not be able to understand. Then this particular app, what they have created, what it will do is, he can just have that app downloaded on his mobile, this one. He can just speak in his own language. Suppose if you're talking about Telugu, he can tell that, hey, I need, for this particular scheme, I need details. He will tell in the natural language, Telugu or Kannada or Tamil or whatever. What the app will do is, it will take the speech, it will recognize that, it will convert that into English, it will go to the websites, government websites, it will search for whatever the scheme he's looking for. He will pull the data, again, that data will be English. He will convert, that app will convert that information back to the native language, and then back to voice, and then provide as a response instantaneously. In the sense, the machine is going to give an answer to that person in his own language after doing all this back work. So when you get a time, there is a video and all that. You can just try it out. It will be so good, right? So that is the power of natural language processing. And if you really talk, you'll have natural language understanding is one part, and generation is another part. Anyhow, you'll use ML and all is fine. But I think that is what is the key thing. And if you really see use cases, there are many. But I think I can say this customer service is one of the key thing, because always we need to either speak in the, if you are here, you'll either need to speak in the English or in the local language. But with the advancement of NLP technologies, the person can probably speak in his own language. It gets translated to whatever the other side want to listen to. Then it gets, again, the response converted back to the person's native language. I think that is one of the key, what you call use case we all can think about. And there are so many tools in the sense how it all works means it's more about tokenization. Tokenization in the sense, if you're speaking something, it also need to identify what is proper noun, what is parts of speech, what are adjectives, what are verbs. That is nothing but your tokenization. And then based on that, you need to understand what the sentence is trying to convey. It's all will be driven by some of the algorithms and all. And there are so many such things. Anyhow, if you're really interested to dig deeper, I think you can always go and explore about NLP tools. You can find all these individual tools which can talk about various aspects to deal with the natural language processing. And one of the important things, these are very important things in the NLP. Stemming. Stemming is what? Because you are getting what you call a particular term in multiple ways. What you will be doing is you will be trimming all that into some form. So dogs means dog, jumping means jump. So this is the way we will do. But this stemming, you cannot bring it to base form always, because sometimes no, this will not be straightforward. That is where you need to do lemmatization. Because, like for example, wives, if you do a stemming, it will give you a wife, which is not correct, right? It needs to be a little more smarter in converting wives to wife. So it needs to know when this kind of thing works or when this kind of things work. So this is more little more smarter in terms of what you call detecting that. And the last thing is entities. So if at all, if I say Reliance means, it should be able to tell, hey, this is an organization. If I put a name, Dilip means it should tell, hey, this is a person, right? That is called as named entity recognition. These are some of the interesting concepts and techniques we use in the natural language processing. So I think this is that the second half of the story, which is about the data science, what it is, how it is, and what are all the various things available, and what are all the tech stacks we have, what is NLP. So this is what about the second half. So now we are slowly heading towards the climax. So the climax is what I want to really talk a little bit about, the document processing, which is going to be the key portion which I work mostly. So that is the reason I can talk more on this topic. But before that, I just want to again take a pause and ask if you guys have any questions or comments. Dilip sir, all good?
Yes, sir. All good, sir. I think in chat box also very informative session like that they posted, sir. Very nice.
Oh,
informative. Yes, sir.
okay. Yeah, sure. Yeah. So the next part is the document processing. So before document processing, I told you, right, documents are the key. And if you all really look at our journey in the information world, how we all started, how we used to communicate, right? So how all that, see, starting from Stone Age till the computers, how that information is evolving, right? We used to write on the stones, then we kind of started writing on the leaves, and then we started getting the paper part, and that is the way we started communicating. Then we got all this medium like radio, television, and all that, and now the computer. So I think this is an evolving area. Information journey is like from 2000 BC, or I think it is what, 20 lakh thousand years BC to whatever it is only showing till 2008 from the Wikipedia. But the intent here is that the information has evolved so much, right? Now the next point I want to talk about is, now we have come to the paper stage, and we have seen the digital transformation slide, where now we said for any organization to take the path of digital transformation, we need to really take the journey starting from the paper documents. First, you need to convert them into scanned or digitized documents. That is the first step. So now you might be wondering, okay, now I converted this physical paper document into a scanned image. The image may be like, say, in a TIFF format or in a what you call a JPG format, whatever, a PDF format or whatever. If it is an Excel, you will be easily know, hey, for example, we have seen this Excel, right? So we easily know because of the cells and all, you can easily say, hey, this 3 is F4, this is F5, this is G5. So your program can easily, through some APIs and all, it will be able to easily read, right? This Excel reading or these things are very easy, or even reading from database and all that. But when you really do that in a, what you call, from the image is nothing but like a photo, right? How you can read, how the computer can understand, because it is all pixels, right? It is all pixels. How the computer can understand, hey, for example, even if you take this slide, how it can understand this is water. Because we understand, we are more smart, we can say this is water, power is something we can read easily. But how the computer can read it? That is where we got this technology called computer vision has come into picture. It is like to mimic how the human beings are having or applying or using their vision versus how the computers are viewing and visioning things. So computer vision versus human vision, right? I think that is the way this has started. So once they started, then first we'll take the documents, means all the characters. Logically, if I ask you, if I want to say, for example, I'm just telling my interpretation. If I want to read this water power, for example, if I want to read this word, how is that I need to understand? How, basically, just imagine how as human beings, we understand it as water power and try to see whether we can build something similar for a computer or a computer vision. So how I am really looking at this and understanding it as water power means, from the childhood, I have been programmed, I have been trained from the time I started my schooling. I know that, hey, W is always here, W is like this, A looks like this, T looks like this, E looks like this, R looks like this. We were practicing, and it has been built in our consciousness. So that whenever we see something, we'll be easily tell that this is W. But if you go a little deeper, how the our brain is going to understand this means, there are two ways. One is, I might have seen this multiple times, so the thing is, it is all there in my memory. Water, okay, water. That is one way. Then even if you want to go one more level, how I know this is W means my mind already got, or my brain already got trained that W means there will be how many lines? 1, 2 lines, 2 inclined lines, or 4 inclined lines connected, right? Something like that. Or if you take, for example, it is more about how the brain is thinking is looking at these lines and the angles at which these lines are put together, the angle between these lines, all these things are something mathematically the brain is programmed to understand and remember this. And for example, if I write something like A, means it, okay, 2 slant lines and 1 diagonal line. That is what is A. So I think there are two things. One is, I have some experience of seeing this again, so I don't need to do or give any effort to my brain. Initially, when you are a child, when you are learning alphabets, how your brain will remember this is, it will frame some kind of rules in its mind. A means there will be 2 slant lines, in between 1 horizontal line. That is the way the brain remembers. That is the pattern it remembers. But eventually, once you keep doing again and again, reading a lot of things, then you don't need to go into that mathematical these things, because now you got experience in that. You got patterns you have seen. So you have used water in many contexts. So you will be able to easily understand what is this, right? So all this, how the machine has to recognize a character or a number, is done through a technology called computer vision. And if you really take a subset of the technology, is called OCR, the optical character recognition. So if you really come little down, what is this OCR? As I was telling, OCR is nothing but a subset of your computer vision. How is it helpful? Means you have a physical document, you have scanned it, you got a scanned file. What is this OCR? Because scanned file is something which will not be able to, for you can read, but for computer, from that scanned image, if it wants to really understand information, it cannot, because it's a photo, it's an image for it. To make it understand, what is that you need to do is, you need to tell it, hey, this is English language. Hey, and you need to give so many samples to it, such that it understands the characters. Okay, this is A, or a combination of, say, CAT is always cat. So you will train it with. Once you scan the document, scanned image is nothing but bitmap. This will be analyzed for how the computer understands whether it is really. This one means, if you really see, if it finds some color, dark color, then it recognizes this as, okay, there is some value to it. It can be an alphabet or a number. If the color is light, then it can probably interpret that as a background. So only this is the way it will identify. And once the dark side has been detected as a character, then the next step is what this character is, whether it is A, B, C, D, whatever. So there are two techniques here. The pattern recognition is, because if you have already fed it with a lot of such similar text with fonts and formats and all, then it will do the comparison and it will do pattern recognition. If not, as I was telling, they also can have some kind of angled lines, cross lines, and all that based on that. No, for example, if you take here, the example is the capital letter A may be stored as two diagonal lines that meet with a horizontal line across the middle. So that is the way. So that means it has some kind of rule defined so that it will understand what it is, right? And when a character is identified, then you all know ASCII code, right? So it will go and map that ASCII code to that particular character, such that that can be read as part of that character. Then sometimes, no, if at all, if the image is not clear and all that, then probably you may need to proofread to see that whether that is correctly detecting or not. And one other important thing is when you are really scanning it, the scanning has to be in some I can say some metric, some measurement. They call it as DPI, dots per inch. If there are less dots per inch, the clarity or the quality of that character may not be great. But if it is a little higher, that means if it is 300 dots per inch, that means there will be so many dots. That means you can easily, the quality of the extraction will be better. Okay, so this is basically the OCR, the optical character recognition, through which now you will be able to understand from an image what is the text. Then you may be wondering, okay, Sharath, you are telling all this. Where is that I'll be using it? Means, if you really put an image, and if that image has a lot of text, will you be able to search? You will not be, right? Suppose if you take, for example, you took a book, you all scanned that book, say 200 pages. And if you really want to search for something, you will not be able to search because that is an image. If it is a text file, you will be able to search for the text. If it is an image file, you will not be able to, right? So for that, what you need to do is you need to use this OCR to convert that. That way, what happens, you can search anything on the content. Then after that, you can also extract the text from there. For example, I'm just give public sector, libraries, archives, they all do because they have so much of content. And there is already a storage optimization, consumption for external applications. Storage optimization is the image always carries more file size compared to the text file. So if you can extract the text, I think you don't need to store the image. You can just store the text. That way, I think your storage will be optimized. The consumption for external applications. Zonal based is always, if you want to define some area where that particular zone, only that particular zone detect means it will be able to do that. Not only that, handwriting, different languages, all that is possible through OCRs. But all OCRs may not be able to do that. But I encourage you to explore. There are many open source OCR technologies. And for every artificial intelligence or machine learning document processing task, OCR is the first step. Once you do the OCR, once you get the text, for that text, we will apply the AI/ML techniques to really attach the context, in the sense what it is. And after that, you may be able to attach your Gen AI to even summarize, to generate more content and all that. So that is the way we need to look at this. Going to the next slide, this is another interesting concept called IDP, that is intelligent document processing. How it starts, how it goes is, once you have the OCR, the image has been, all the text in the image has been converted into, say for example, the text. The text is probably something given to, the text is in the form of a JSON file, or it can be form of a CSV file or whatever. So now what is that you need to do is, you have all the text now, but you don't know what text belongs to what. Suppose if the scanned image is, say, invoice document. So if you really want to make some sense out of that content, because OCR will not tell this is invoice number, or this is invoice date, or this is customer name, or this is customer address. OCR will not tell. OCR only will convert the image from image to a text. That's it. But it will not be able to, it doesn't have the intelligence to tell what is what. That is where your AI/ML techniques will come into picture. So the output from OCR will be picked by the IDP, the intelligent document processing, and it will start processing. So I think this is probably duplicate. I can just remove this. So if you really see here, this diagram, first step is ingestion, in the sense, if you got a document from here, say for example, a JSON file is created or a CSV file is created. Now what is that you want to do is, or say for example, a PDF file is created. You got here. Now you got the PDF file, that PDF file is something you are going to ingest to this platform. What is going to happen is pre-processing. What is pre-processing? Pre-processing is something which you will be able to do, based on some beautification or something you want to do on the data. You can do that. That is what is your pre-processing. Okay. And this pre-processing, once you've done, I can tell you one example. Some of the tools may be accepting only, say, PDF files for the processing. But you have that image in a TIFF format, or you have that image in a JPEG format. So your pre-processing is something like, you will convert the TIFF or JPEG into PDF as part of this pre-processing step. Once you convert this, then you will be classifying. For example, I am ingesting, say, purchase orders and invoices here. So, but I want, because the OCR will not tell whether this is a purchase order document or this is an invoice document. Who will tell that? By applying the AI/ML techniques, the IDP will classify the documents, whatever the incoming documents, and tell that, hey, this is purchase order. Hey, this is invoice. How that all will happen means, we will train the document. So in the sense, again, I was telling in the Excel sheet, okay, this is the training set and this is the test set. Similarly, what I'll do is I'll probably take 25 or 30 documents, and I'll tell to the computer that, or tell to this thing by labeling it, hey, this is an invoice, this is an invoice, this is a purchase order, this is a purchase order. Then after that, it gets trained. And similarly, I'll also do the extraction. That means extraction means, from that, suppose even if you identify it as a purchase order, from that, I want to extract the purchase order number, I want to extract the date, I want to extract the invoice number, I need to extract the invoice date. I'll also label and train the extraction part. So once all that is done, next time when you provide a new document, because it is all trained, it will easily tell, first classify it as invoice document, and it will also pull the invoice number and invoice date. That is what this ADP is going to do. And you can also put some post-processing, if at all, if you want to really remove any noise and all, you can do that. HITL is something human in the loop. Sometimes whatever you may see, because if the quality of the document is not good, when it extracts or when it classifies, it gives them confidence score. Mathematically, it says, hey, I am only 90% sure that this is, say, for example, if it says Reliance, whether it is, I'm only 95% sure it is coining to the word Reliance. So that means what we need to do is we need to put a human, in the sense we need to put a human operator in the loop, who will really read by eyeballing that and then telling, hey, this is probably this needs a correction or whatever, right? I think that is what is the human in the loop. Once all that is done, what happens? The documents get segregated. That means an image from here gets classified, gets the data pulled, and that data and this thing can be stored somewhere. And also, it need not be storage. It can be external system also, in the sense, for example, I have an ERP system, or you have an education system, or you have some learning management system. So the data can also go to any of this, in the sense I can say probably any external system. Say, for example, I'm saying LMS. So this also may go to an LMS, this data, such that that can be consumed by whoever is using that. So this is about the same thing. I just put it in a neat way to really showcase you how this all goes through. You are getting documents in multiple formats. You are getting through emails, printer, whatever. Then you are doing some pre-processing, conversions, whatever, splitting. Sometimes your invoice and purchase order may come together as one bundle. Then you may want to really split it. That all can be done in your pre-processing. Then you can do classification, extraction and all. Then you will be doing all the post-processing, validations, HITL. Then you can send it to your LMS or other systems through integration, connectors and all, right? I think that is the way it will be looked at. Then I think we are almost come to a state. I just want to conclude by talking a little bit about Gen AI. So this is basically, so what is this LL? You might be seeing a lot of generative AI and large language models and all. So large language models is nothing but your completely text-based modeling, right? So what is this large language models is? Now every company is, suppose if I am doing an invoice, I am training my own model. Similarly, if some other company is doing, they may train their own model. Instead, the large language models is, they have taken from the public domain whatever the invoice available from so many enterprises, and they trained the model in a way that can be generally used by anybody without doing anything. It can be directly used. That means it can cut down on the training part. It doesn't need so many samples. It can be easily generate the content by itself, right? So that is where these LLMs have started. So the LLMs have started, and then you can see that the LLMs have whatever the GPT, you might have heard about GPT, right? And those GPT is what is the open chat GPT, and what do you call the OpenAI is what has come out with the chat GPT. The chat GPT is nothing but a UI version of it, right? And similarly, the LLMs have, after seeing the chat GPT, GPT and all, GPT-3 and all, the Google has come out with Lambda and Bard. Bard is nothing but equivalent to your chat GPT for OpenAI. Similarly, Facebook has Llama. I like that. I think they keep developing and all. But the intent or the objective of this is more to make things easy for us. For example, if you take a court judgment, generally the court judgments will be what? They'll be in 1,000 pages, 2,000 pages, 1,000, whatever. Suppose if I don't have patience to read all that, I can give it to this generative AI. Hey, can you summarize me this document or judgment? Means it can give you a one-page summary of that particular entire 1,000-page document. So that is the kind of power it has, right? And similarly, if you have a big financial statement, balance sheet or whatever, and if you really don't want to read all that, but if you want to really ask the Gen AI, hey, tell me what it is really trying to, whether we are going, whether the health of the company is good or bad or whatever, it can immediately tell that, right? So I think these are all the typical use cases we have. I think generative AI is itself a big topic, so I think we can talk about it. But yeah, I think more or less this is what I'm trying to cover. I'll try to see if at all. I think these are some of the things I already told you all the tech stack, and also you already know. And for the career options, I already listed some of it here. So you know who all will do what. I also have some definitions in the below. Oops. So these are all software engineers, more about all using all the integrations, APIs, interacting one system to another. All that is what your software engineer will do. Data engineer is about all the data curation, transformations, if at all, if it is unstructured, how to clean it, and how to identify outliers. All that is your data engineer's job. Data scientist, science analyst is all training, labeling, aggregation, metrics, analytics. All that is what your data science analyst will do. Machine learning analyst, engineer will do modeling, sample ML algorithms, experimentation, testing, and all. Data scientist will be looking at new algorithms, new ways of dealing with this, whether one algorithm performs better than other algorithm, which algorithm is suitable. So constantly evaluating, evolving, and all that is what is the data science option. So I think that is pretty much it. One second. Yeah, I think that's pretty much it, Dilip. I'm hope I think.
Yes, sir. Yes, sir.
This helps you guys, and I assume that it gives you some glimpse about data science and its applications and all that. So I think that's pretty much my climax, Dilip, and
Yes,
over
sir.
to you.
Yes, thank you. Thank you. Sir, participants, any queries? Okay, sir. Dear sir, on the behalf of Narsimha Reddy Engineering College, School of Computer Science, we are highly appreciate your sir, your presentation and deliberation as a resource person for this FDP in a technical association with a Computer Society of India, Hyderabad chapter. We would like to convey our sincere thanks and gratitude for your fruitful session overview on your data science. Your session is enriched the participants, the workshops with the knowledge and created the intellectual environment. We will feel honored to collaborate with future also, sir. Thank you, sir, for your valuable time and valuable seminar, sir.
Thank
Very
you.
much.
Thank you,
Yeah,
Dilip, and thank you, everybody, and nice interacting with you all.
yeah, thank you, sir. Okay,
thank
sir.
you.
Thank you very much, sir.
Thank you. Bye then. Take care.
Okay, sir. Thank you.